Okay, today we're going to talk about drawing the graph of a quadratic equation, which is the graph of a parabola. And we actually did this back in section 3.1, where we started with the basic equation and then applied transformations to move the parabola around to get the final result. So the problem with this is we need this form here. Our quadratic equation has to look like that so that we can apply the horizontal shift, the stretch or compress, and then finally the vertical shift. And we can do that starting with the standard quadratic equation, but the problem is we need to complete the square. It gets a little bit confusing, and then if we do that correctly, we wind up with this form here, and then we can go ahead and apply the transforms, and again, we got to remember what they are, and we got to apply them in the proper order. So let's go ahead and do one, even though there's really a better way to do these things. So let's pick an example here. Let's see what I have. Okay. Let's try this one. This is a pretty good example. What we need to do here is complete the square right here and turn this into a perfect square. And again, when we complete the square, we just want a 1 here. So the first thing we want to do is factor a 4 out of here. So let's look at that. Now, let's leave room for the number to complete the square. Half of 6 is 3, 3 squared is 9, so we would need a 9 here. Now this time we need to be careful. By adding a 9 to the equation, we actually added 4 times 9 to the overall equation. That's 36. But we don't want to change the equation, so if we added 36, we need to take 36 back out. So this is what we need to do. Now we've completed the square here. This becomes x minus 3 squared. And then if I take 36 and I minus 15, that'll be minus 21. And now we have this form here. So if I started with the basic parabola with the vertex at the origin, we would shift to the right 3. We would stretch it by a factor of 4, and then we would shift it down 21. Okay, we could do that, and that's a lot of work. Let's try this another way. Now, with any equation, you can set up a table and pick x and y values. That's not a good idea on curves because you can pick a lot of points before you get to any points that's going to show you where the thing curves or where the vertex is, those kind of things. So that's a difficult way to go. However, we can get the points right there from that equation that we need to graph this thing. So let's look at that. All right, first thing, Last time we talked about the y-intercept, so that's just c. So we already have that. So we got a point right now, we didn't have to do any work. Y-intercept is 15, so we'll eventually plot the point x equals 0, y equals 15. Okay, what about the vertex? We know what we're going to have to do here to calculate the x-intercepts. We'll probably be using the quadratic formula. But let's get the vertex first to make sure that we have x-intercepts. So the vertex turns out to be pretty easy. There's a formula, and that's going to be the vertex formula. And that formula is simply minus b over 2a. So if that's the x value, then the y value would be the function at that point. That's how you calculate the vertex. So let's do it. Minus b over 2a. Up here, b is minus 24, so that's minus a minus 24 over 2 times a, which is 4. So 2 minus, that's a positive. 24 divided by 8, that's 3. So f of 3, if I plug that in here, or in our case, I'm sorry, g of 3. Let's change this to a g also. Okay, g of 3, 4 times 3 squared, minus 24 times 3, plus 15. I already figured all that out. Let's see here. Comes to minus 21. So if you figure all this out, you'll get minus 21. So what does that mean? That means our vertex equals the point x equals 3. The function is minus 21. So now we have 2 points. And if you notice, a is positive, that means it opens up. But the vertex is at minus 21, which is way below the y-axis. That means we're going to have 2 x-intercepts. So now let's go ahead and find them. What we're going to want to do here then, probably the easiest way, you could factor this, but probably the easiest way would be to just use the quadratic formula. So for the x-intercepts, we're going to have x equals negative b, and b is a minus 24, plus or minus b squared minus 4 times a, which is also 4, times c, which is 15, over 2 times a, and a is 4. These two become a plus, and there's a lot of work here again. I already did it, so let me just write down what we got here. Okay, I have 24 plus or minus the square root of 336 over 8. Unfortunately, that's not a perfect square, so we just have to estimate it so that we can graph. We'll estimate it to the 10th because you're not going to be able to get any finer on your points anyways. So this winds up being 24 plus or minus 18.3 over 8. So if I add these together, that that's going to be 42.3 over 8, which is going to equal where is it here? 5.3. If I subtract these two, then I'm going to get 5.7 over 8, and that's going to equal roughly 0.7. These are my x-intercepts, so we plot this point and this point, and that should be all we need. So let's look at it. We're going to set up our axis, so I need a lot of y-axis here. I'm going all the way up 15 and all the way down to minus 21. However, in the x direction, we're not moving that much. In fact, we don't go negative at all. So let's set up something like this. So 5, 10, 15, 20, 25, 5, 10, 15, 20, 25, and we'll do ones here. 6. Okay, let's start with the vertex. Vertex is at x equals 3, y equals minus 21, 5, 10, 15, 20, 21, just a little bit further down, about there. And then let's go ahead, this isn't required, but sometimes it just helps to go ahead and put a dashed line in for the axis of symmetry, just so you can see the curve better, and kind of helps with the drawing. Again, it's not required. Okay, we have x-intercepts. 1, 2, 3, 4, 5, and a little bit more, so there's 5.3. And 0.7, that's almost 1, but not quite, so that's about there. And then we have a y-intercept way up here at 15, 5, 10, 15, right here. Now, if you want to add one more point, you got one here almost as a bonus, because points are equidistant on either side of the axis of symmetry. So for example, if I'm at 3 here, this point is 3 away from the axis of symmetry. That means if I go 3 more the other way, keeping it the same y level, so 1, 2, 3, that's got to be another point there. They mirror each other. Okay, so that's it. So now you just do the best you can to sketch it. I kind of missed that one, but there you go. So let me go ahead and do one more, and that should do it. Okay, let's try this one. This one will have a little something different happen, so it's a good example. So we have x squared, f of x equals x squared plus 4x plus 5. Again, what is the y-intercept? C. So y-intercept is 5, or the point x equals 0, y equals 5, if you want to think of it that way. What is a vertex? Again, the vertex is, start with minus b over 2a. So b is 4, so that's minus 4 over 2 times a is 1. So that's just going to be equal to minus 2. And then the other coordinate of the vertex is just f at this, x coordinate. So f of minus 2 equals minus 2 squared. Again, notice the parentheses here because we're squaring a negative is going to become a positive. Plus 4 times negative 2, again the parentheses here, plus 5 equals, here we're going to have 4 minus 8, so that's minus 4 plus 5, that's 1. So our vertex is at x is minus 2 and the function is at 1. Okay, next we would calculate the X-intercepts. This looks like it might be hard to factor, so we'd use a quadratic function. But the quadratic function is a lot of work, and we don't have to do it in this case, because take a look at what's going on here. A is positive, it opens up. The vertex is at y equals 1. That's above the x-axis, so there are going to be no x-intercepts. So if we try to find x-intercepts here with the quadratic formula, we're just wasting our time. So let's take a look at what we got, and we can generate a couple other plot points by using tables or other methods. So what do we have here? We'll do everything in ones here. Oh, we know it doesn't go down there. Vertex at x equals minus 2, y equals 1, so we're here. Y-intercept is at 5. 1, 2, 3, 4. We need another one here. So y-intercept is here. Okay, let's go ahead and draw that axis of symmetry. It just kind of helps. And in fact, we can pick up another point right now. This is 2 units away. So if I stay at the same y level and go 2 units this way, there's another point. And we could really sketch it right from there. If you want to generate more points, you could put x equals minus 1 in and see what you get for y. And you could generate that point. You'd have the mirroring point on the other side, but I don't think we need it. We can sketch it from here. And it looks something like that. So that's it. So next time, and this will be the final part to section 4.1, we're going to look at basically reading word problems, setting up a quadratic equation from the word problem, and then if it opens up, hopefully the problem would be asking for a minimum, and basically all we do is look at the vertex and we look at the y coordinate. We're just trying to find the minimum or the maximum for the function. If we get a word problem with a quadratic equation where we have a negative a, then that means we would be looking for a maximum. So we'll see how all that works next time.